We live in a world powered by connections. Just like the stars form galaxies, our devices come together to form networks. A computer network is simply a group of devices that can talk to each other. These devices could be computers, phones, printers, or even refrigerators. Networks allow us to share information and resources. Imagine trying to send a photo to a friend without the internet. It would be much harder. Networks have revolutionized how we communicate, work, and play. From the moment you wake up to the time you go to sleep, you're interacting with networks, checking email, browsing the web, streaming music. All these activities rely on networks. Understanding how networks work can help you appreciate the complexity of our digital world. This essay will explore the basic concepts of computer networks. We will delve into the different types of networks, how they are structured, and the languages they use to communicate. Get ready to unravel the mysteries of the networked world. To understand networks, we need to start with the basics. Every network is made up of nodes. A node is any device connected to the network. Your laptop, smartphone, and even your smart TV are all nodes when they connect to a network. When you send data over a network, it is broken down into small chunks called packets. Think of packets as digital envelopes. Each packet contains a piece of the data and information about where it needs to go. But how do these packets know where to go? That's where protocols come in. Protocols are sets of rules that govern how devices communicate on a network. They ensure that data is transmitted correctly and efficiently. Imagine protocols as traffic signals for data. They direct the flow of information, preventing collisions and ensuring everything reaches its destination. Without protocols, our digital world would be chaotic and unreliable. Not all networks are created equal. We can classify networks based on their size and geographic scope. A local area network, or LAN, connects devices in a small area, like a home or office. A metropolitan area network, or MAN, covers a larger area, such as a city. Wide area networks, or WANs, like the internet, span vast distances, connecting devices across the globe. There are also specialized networks, like personal area networks, or PANs, that connect devices within a very small range, such as Bluetooth headphones to a smartphone. Wireless local area networks, or WLANs, use Wi-Fi to connect devices without cables. Virtual private networks, or VPNs, create a secure connection over a public network, like the internet, allowing you to access private networks remotely. Each type of network serves a specific purpose, catering to different needs and scales of communication. The way devices are connected in a network is called its topology. There are several common network topologies, each with its own advantages and disadvantages. In a bus topology, all devices share a single cable. A star topology connects all devices to a central hub, like a router. A ring topology connects devices in a circular pathway, while a mesh topology connects every device to every other device. The choice of topology depends on factors like cost, reliability, and scalability. For example, a star topology is easy to set up and manage, while a mesh topology offers greater redundancy and fault tolerance. Understanding network topologies is essential for designing and troubleshooting networks. The right topology can optimize network performance and ensure reliable data transmission. Section 5. Layers of communication, the OSI and TCP/IP models. To manage the complexity of network communication, we use models like the OSI, which stands for Open Systems Interconnection, and the TCP/IP model. These models divide the communication process into layers, each responsible for specific tasks. The OSI model has 7 layers, while the TCP/IP model has 4. Each layer interacts with the layers above and below it, passing data up and down the stack. Think of these models as an assembly line for data. Each layer performs its specific function, adding headers and trailers to the data packets before passing them on to the next layer. This layered approach simplifies network design and troubleshooting. Section 6. Speaking the language network protocols. We've already learned that protocols are sets of rules for network communication. Let's explore some essential network protocols that enable our digital world. TCP, or Transmission Control Protocol, is like a reliable mail service. It ensures that data is delivered reliably, breaking it into packets, numbering them, and reassembling them at the destination. IP, or Internet Protocol, is the addressing system of the Internet. It assigns a unique IP address to every device on the network, allowing data to be routed correctly. Other protocols such as UDP, HTTP, FTP, DNS, and DHCP each play specific roles in facilitating web browsing, file transfer, domain name resolution, and IP address assignment. These protocols work together seamlessly, allowing our devices to communicate and share information effectively. Section 7 Services provided. What networks do for us. Networks provide a wide range of services that enhance our lives. Connectivity is the most basic service, allowing devices to establish communication channels. Data transfer services enable us to share files, stream media, and access online resources. Security services protect our data from unauthorized access, ensuring privacy and confidentiality. Remote access services allow us to connect to networks from anywhere in the world, while management and monitoring services help administrators keep networks running smoothly. From basic communication to complex business operations, networks provide the foundation for countless applications and services that we rely on every day. Section 8. The Internet, a network of networks. The Internet is arguably the most well-known and impactful network in the world. It is a vast network of networks connecting billions of devices worldwide. The Internet has its roots in the 1960s with the creation of ARPANET, a US government-funded research project. Over the decades, the Internet has grown exponentially, evolving from a niche technology to a ubiquitous part of our lives. The Internet has revolutionized communication, commerce, education, and entertainment. It has empowered individuals, fostered innovation, and connected people across cultures and continents. From email and social media to e-commerce and online learning, the Internet has transformed the way we live, work, and interact with the world around us. Section 9. Conclusion: Networks in our lives. Computer networks are the invisible threads that connect our digital world. They enable us to communicate, collaborate, and access information in ways that were unimaginable just a few decades ago. Understanding the basic concepts of computer networks is essential for navigating our increasingly interconnected world. From the different types of networks to the languages they use, each component plays a crucial role in enabling seamless communication. As technology continues to advance, we can expect networks to become even more sophisticated, connecting us in new and innovative ways. By grasping the fundamentals of networking, we can better appreciate the power and potential of this transformative technology.